In this video, this extract is showing the auditor auditing aspects of the deployment of process failure mode and effect analysis. Watch this video and see whether the auditor is auditing effectively. So I want to follow through then. When we were looking at the performance data for the aluminium printing, we can see that one of the issues has been about contaminated parts. So could you give me some of the potential reasons that we could get contaminated parts and what you're doing to try and prevent or detect that?
No, yes, you're right. The contamination of our parts is the highest risk for scrap. So yeah. This is the biggest challenge, to have here clean room conditions, a very clean air, and our last improvement to hold this is the this plus air filter.
So, yeah. And take me through what you're monitoring on this then.
So with the device here, we monitor the air particles in the air, who are directly in the air. And if they are less as possible, we have the best quality what we can have.
Right, okay. And what's the acceptance criteria in terms of the particle size and number?
So we measure from 0.0 micron up to 10 micron.
Okay.
Interesting for me are sizes higher than 1 micron.
Yeah.
Because they can infect, or they can be visible on the aluminium sheets. And what we measure here, we make also a statistic. We measure 4 times a day.
4 times, yeah. Yeah.
And if we see that we are out of the range in the concrete, if we have more than 5 particle bigger than 10 micron, we stop the production.
Okay, and what could be the cause of that then, that we've got the high particle count?
Incoming people and incoming materials.
Okay.
Because from the air system we get ultra filtered air inside. There is 0 particle inside, so the biggest risiko are we, the operators himself and the operator who take the material inside the clean room.
And how do you try and minimize that risk? I know the risk is always there, but how do you try and minimize that?
We have several clean steps outside. We have locks, personal locks, material locks. We work there also with air pistols to blow up the dust before they come inside, but we cannot reduce it 100%, and also let's say arrest risiko stays, and we here to know what happens inside directly in front of the production.
So I see through the action you've already taken then that you've reduced the risk in the PFMEA from high to medium. Have you got any other actions planned regarding control of contamination within this area?
Yes, we have. The next step is that we install here on the production row all 2.5 meter anti-static bars. This will be also a big help to prevent inclusions and scrap.
And what is the timescale for doing that? How long do you think that's going to take to do?
The next week.
Oh, this soon?
The installation, it's still ordered, and the next week the bars will be installed.
Right. Okay. No, so thank you for your input. So from what I see, you've identified this as a risk in the failure mode effect analysis. You've already taken action that is resulted in a reduction of the risk. I see from your control plan that matches that you're doing the check 4 times a day, and the reaction plan is that you would stop the production if you see the high particle count. So what you've told me matches your process documentation. So thank you for that.
You're welcome.
So the key learning points. One of the key documents that auditors should focus on in auditing IATF 16949 is the process failure mode effect analysis, shortened to PFMEA. The auditor should be looking at how the PFMEA has been created, taking into account the design failure mode effect analysis and the process flow diagram. And then what the auditor should do is focus on areas of the highest risk. Within this video, we could see that one of the risks that has been identified is that the product has to be manufactured in a clean room environment. And particle count is one of the key measurables to make sure that the clean room is the right quality to make sure that we can make conforming parts. The auditor was challenging how the particle count is monitored and what happens if the target is exceeded. And what the organization said is that if the target is exceeded, they should stop the process. The auditor was also using the PFMEA in this part of the discussion. This organization was using the AIG VDA format for PFMEA, and obviously within that, risk can be quantified as high, medium, or low action priority rankings. The auditor was challenging actions that were being taken to reduce risks that have been identified. Also, auditors should be looking at the interface between the process failure mode and effect analysis and the control plan. So let's summarize. A key aspect of any IATF 16949 audit is checking the effective implementation of the process failure mode and effect analysis, focusing on the areas of the highest risk that have been identified, including any special characteristics. But also, auditors must focus on the effective interface between the process failure mode and effect analysis and the control plan, and then the deployment of the control plan into the relevant work instructions.